Hi everyone, let's continue with few more examples on designing of DFA where string ends with AB. First, identify the condition, understand it. Here string should ends with AB. Last two symbols should be AB. But before that anything is allowed, maybe multiple A's or any combination of A and B or anything. But all these string should end with AB. Based on this, try to write down minimum length string. What's the minimum length string in this condition? It should end with AB. So AB itself is the minimum length string. It's ending with AB. Or we can say if last two symbols are AB, before that A can come. If last two symbols are AB, before that B can come. Or we can say if last two symbols are AB, multiple A's can come. Or multiple B's can come. But our last two symbols should be AB. Once we have written the minimum length string set, start designing DFA for this. As DFA consists of multiple states, states are represented by circle. Q0 is our starting state. There is no epsilon, so Q0 is not final state. AB should get accepted. It means what? By reading AB, automata should go to the final state. One state read one symbol at a time. So Q0 reading A will go to the state Q1. Next symbol is B. Q1 reading B. It's going to state Q2. As AB is the minimum length string set, it's a valid string. It's ending with AB. So transition for this A and B should go to the final state. So I'm making Q2 as a final. Once Q1 is reading the last symbol B or AB is completed, automata is going to final state. Hence AB is getting accepted. Now once we design automata for our condition, then start making automata as a deterministic. Deterministic means what? There must be one transition for each symbol of sigma. From Q0 there is a transition for A, but transition for B is missing. Then how to make any state deterministic? Write down the state here as a target state. Here I want to make Q0 as a deterministic. For which symbol? Symbol B. There is a transition for A, but transition for B is missing. Then find out the path. Path should be like this. This is our uniform method. You can follow this in all examples. It's very simple. How to reach to Q0 from starting state? In this case, Q0 itself is a starting state, so nothing will be here. How to reach to final state from Q0? Q0 to final state by reading A and B. So write down here AB. Ask yourself, is this valid string? Yes, because it's ending with AB. This is a valid string. Q0 is looking for single B or multiple B are also possible. Multiple B's are also possible. This AB as it is, Q0 to final. Again check, is this valid string? Yes, it's ending with AB. Similarly, if multiple B's are coming, maybe 1, 2, 3, 4, but this AB will be as it is. All these strings are valid because all strings are ending with AB. Or we can say, if path from Q0 to final is AB, if no B's are coming, no B means what? Epsilon. It means what? Q0 is looking for 0 number of B's or 1 number of B or 2, or we can say many number of B's. Hence at state Q0 scenario is like 0 or many B. And as we know, in my all previous videos we explained that if there is a scenario of 0 or many, simply give the self proof. For which symbol? Symbol is B. Now Q0 becomes deterministic. Now let's make Q1 as a deterministic using the same uniform method. Write down the state which we want to make deterministic. Your target state is Q1. From Q1 there is a symbol transition for B. We are going to find for A. How to reach to Q1 from starting state? Starting to Q1 by reading symbol A. Q1 to final by reading symbol B. For which symbol we are trying to find transition? Symbol is A. This A and B as it is. Ask yourself, is this valid string? Yes, it's ending with AB. The string is AAB, but it's ending with AB. It's a valid string. Q1 is looking transition for single A or double A is also possible. Starting to Q1 A as it is, Q1 to final B as it is. Is this possible? Yes, it's possible. And is this valid? Yes, it's ending with AB. This is also valid string. If suppose Q1 is trying to find transition for AAA, starting to Q1A, Q1 to final B as it is this valid? Yes, again ending with AB. So all these are valid string. It may happen that at Q1 no A's are coming. No A means what? Epsilon, 0 number of A's. Still this string becomes valid because A epsilon B, this becomes AB, as epsilon is empty string. Again string is ending with AB. This is also valid string. Hence we can say Q1 is looking for 1A, 0A, 1A, 2 or 100 A's. So there is a scenario of 0 or many. So at Q1 we are looking transition for 0 or many A's. And as we know, whenever there is a scenario of 0 or many at state Q1 here, so give the self loop for which symbol? Symbol is A. Hence Q1 becomes deterministic. Now let's do the same thing for the state Q2. We need to make Q2 as deterministic. We can follow the same approach. What is the approach? How to reach to Q2? As I want to make Q2 as a deterministic. How to reach to Q2 from starting state? Q0 is starting by reading A, by reading B. Write down here AB. How to reach to final state from Q2? By reading nothing. So here will not be any string. For which symbol we are trying to find transition here? At this moment we are trying to find, for example, for A. Ask yourself, is this valid string ABA? No, this is not valid because our condition is string should end with AB, but this is ending with BA. So we can say, I will write the same string here, ABA. We can say this is not valid, but we can also say this can become valid. How? Because as we know, whenever there is a question ending with AB, we cannot formally say this is the last symbol, because after this any symbol can come. If this is the invalid string, try to make it valid, because we need to consider all the possibilities. After this B can come, because we are trying to find transition for A at this moment, but after this A, B can come and this string becomes valid ending with AB. You may think that after this AB we are trying to find transition for A, after this A may come. Yes, that is also possible, but that possibility we will see later on. At this moment we are trying to find possibility for this symbol A. Now in this case, how to find the answer? It's very simple. You just need to ask few more questions to yourself. I will write the same string here. How to reach to Q2? By reading AB, trying to find transition for A from which state? State is Q2. This is at this moment invalid, but we don't know whether A will be last symbol or not. We cannot predict it. After this A, B can come. If after this A, B is coming, this string becomes valid because it's ending with AB. If it's ending with AB, it becomes valid. At this moment, Q2 is trying to find transition for A. Now find out some other state for this B, because we need to connect transition from Q2 to this state. Once Q2 is reading this A, it's going to some other state. That some other state will read this B and should go to final. Why? Because this is a AB ending with AB. This is a valid string. After reading this complete string, automata should go to the final state. Hence, transition from Q2 for the symbol A should go to some other state. That some other state will read the B and will go to the final. So in this existing automata, which is the state which is reading B and going to final? Q0 reading B going to final? No. Q1 reading B going to final? Yes. So that some other state will be Q1. Hence I can say transition from Q2 for symbol A will go to the Q1. Transition from Q2 for symbol A will go to the Q1. If you want to verify, you can verify. AB should get accepted. See, A, B, again A, again B, getting accepted because it's ending with AB. Now similarly we can find out for another symbol. How to find out? Same approach. You just need to ask few more questions to yourself. I want to find out transition for symbol B at state Q2. How to reach to Q2 from starting state? By reading AB. How to reach to final state? Q2 itself is the final, so our string becomes ABB. At this moment it's not valid, but we cannot also say it's invalid, because we cannot predict whether B is a last symbol. We cannot say firmly B is the last symbol because one state read one symbol at a time. After this B, A may come. Again, this is not valid because our string should end with the AB. But as I mentioned, we cannot say A is also the final symbol. After this A, B may come. We need to consider all the possibilities. At the end, I'm just giving you one trick. Here, whenever you have the questions like ending with AB, if any string, for example here ABB, Q2 is find transition for B. Okay, initially I told you conceptually, but in the exam you can follow this trick. If this is the invalid string, question is ending with, make this invalid string as a valid. I want ending with AB, simply write down here AB. The same case. Conceptually I explained previously, in the exam you can follow this one. Now this becomes your valid string ABB AB ending with AB. Now how to find transition? Simple. Q2 is trying to find transition for symbol B. It should go to some other state. That some other state will read this AB and will go to final. Why? Because it's ending with AB. Any string ending with AB should go to the final state. So that some other state, there will be path from that some other state to read this AB going to final state. In our existing DFA, find out the state which will read AB, or from that state there is a path for AB towards final. It's what? It's a Q0, because Q0 is reading A as well as B and going to final. So that some other state will be Q0. Hence, transition from the state Q2 for the symbol B will go to Q0. Transition from this Q2 will go to Q0 for symbol B, because after this B, AB can come. If AB is coming, Q0 will read this A, B will go to final. If you want to verify, we can verify it. Suppose same string I am writing here, ABB, AB. First symbol A, Q0 reading A, going to Q1. Q1 reading this B, Q1 reading B, going to Q2. Q2 reading B, say Q2 reading B, Q2 reading B, going to which state? Q0. Q0 reading A again, Q0 reading A, going to state Q1. Q1 reading B, Q1 reading B, going to state Q2. So at the end, automata is in the state Q2. Our string is completed. Automata is in the state Q2. Q2 is our final state. Hence this string is accepted. And this becomes our final answer. All states are deterministic. You can practice similar kind of question where string is ending with 10. In the next session, we will see some more complex part of the same scenario where string is ending with ABB. Thank you for watching.